Today's feature request comes from User and Ian from the Discord channel. So thank you so much for the suggestion. And the suggestion is to add arms to our character. Because as you can see on this arm over here, I kind of just have a floating hand. But it's not quite perfect yet. It still needs a bit of work. And once I work out the details, I'm going to update the style of it and make it match the hands and the body a little bit more. So thank you, Ian and User, for the suggestion. Okay, so when I first started thinking about how I want to try to do this inverse kinematics, I was being lazy and I was thinking, what would be the easiest way to do this? And my first thought was to try to do the inverse kinematics the same way I did the inverse kinematics for the boss legs. And on the bosses, their legs, the upper part of the joint and the lower part of the joint are the same length. And when you make it the same length like that, that basically makes all of the mathematical calculations a lot simpler. But I started thinking about it more, and I realized that if this arm is going to be attached to your body, you're going to feel it if it's slightly off. Like the elbow has to be in just the right place, the shoulder has to be in just the right place. And in real life, if you bring your wrist as close as you can to your shoulder, you'll notice that your wrist is just a little bit shorter than your shoulder. So we have to try to make this system mimic how the actual human body works, so it feels just right. So once I decided that I am going to try to do real inverse kinematics to make the arm feel just right, I Google searched some inverse kinematic formulas, and basically inverse kinematics is the calculation of bending your arm to reach and grab something. It's used a lot in video games, it's used a lot in robotics. So I Google searched it and tried to find just an equation that was already ready to go for me, but I couldn't quite find that because all of the calculations were based on an X and Y graph, and it didn't actually use the variable that's just the distance from your shoulder to the point that you're trying to reach. All of the equations that I found didn't seem to need that variable or want to use it using that variable. But what I ended up realizing was that I can measure the distance between the shoulder and our target, and I will know the distance of how long our wrist is and how long our bicep is. And that's three sides of the triangle. So if we know all three lengths of the triangle, we can use that to do a calculation to figure out what the angles are going to be. So I started doing a little bit more Google searching, and I thought, this is going to be so easy. I know all three lengths of the triangle. All I have to do is do a simple calculation. And I found out that the equation that I was looking for was something called the law of cosines. So I will put the equation up on the screen. That is the standard law of cosines. And that is definitely a very useful equation, but we need to change it to make this actually work in a video game. Basically, we need to take the letter C, which stands for the angle of the triangle that we're looking for, and move it over to the other side of the equation. So basically, we're going to do a little bit of algebra and cancel out all of the values on each side until we are left with just the letter C, or the angle that we're looking for. And then there we go. This is the new equation that we're going to use for inverse kinematics. All right, so this is a really basic inverse kinematic script, and it's missing a lot of features right now, but let's go over what we got so far. So first of all, we have a variable wrist target. So we're going to attach this to the hand so that we actually know where we want the arm to reach out to. And before I get too far, I also want to say that in this inverse kinematics script, I coded it sort of backwards. I mean, mathematically it's the same, but this time I'm starting at the wrist and going up to the shoulder. So the shoulder is actually the target. So it's a little bit backwards from the way that most video games do it. The way most video games work is if the target that you're reaching for is farther than your arm can reach, it'll just reach as close as it can. But in Jet Island, I decided that I'm going to make it start at your wrist and work backwards, so that if you reach something that's too far away from your body for your arm to reach, your arm will detach from your shoulder and float away. And I don't know, in some video games that might be really weird, but in Jet Island, you're kind of a robot guy with floaty body parts anyways, so I thought it might fit really well. And more importantly, on your legs, when I do the inverse kinematics on your legs, your feet have to stay attached to the hoverboard. So if the hoverboard leaves your feet, that would be really weird. So I'm going to have the hip joint be able to stretch, basically. Okay, so the next set of variables that we have is basically all the different parts of the arm. We just want to label the elbow, the wrist, the shoulder, just so that we can measure everything. And then we can measure everything like the distance and like the length of our arm and of our shoulder, and save them in these variables here. And then we have one extra variable here called the current elbow up. So basically in inverse kinematics, when you reach for something, the elbow can be like anywhere. So we have to pick a spot where we want the elbow to be. So in this case, and for most inverse kinematic setups in video games, the elbow target is going to be this like invisible point floating kind of behind our back over here. So that way the elbow always knows to use that as our target. And we have it set to an up variable because basically we're having the arm look at our shoulder, and then it's going to use the up variable pointing from the shoulder to our elbow target. I don't know if any of that made sense, but it's basically kind of standard inverse kinematic stuff. So like I said, here's the line of code where we're finding the elbow up. We're figuring out how far away the current target is that we're trying to reach for. We line up the arm with where our arm and hand actually are in 3D space. And then here is the magical line of code that actually makes this an inverse kinematic code. And this line of code, I'll put that equation back up on the screen. So this is the line of code that is me plugging in all of the variables into this equation. So at first I didn't think the equation worked. I figured like, oh, my math must have been bad. But then I remembered, oh yeah, this is in radians. So I have to convert wrist angle from radians to degrees, and then that actually made it move as much as it needed to. But then it was off axis, so I had to switch around like X and Z and line everything up. But once I got everything lined up, then it was working. And learning how to do inverse kinematic code is just a lot of fun, because once you get it working, it's just a really fun, cool mathematical thing to play around with. So that's pretty much all we had to do. The only thing left to do was to actually take this angle once we found it, actually apply it to the wrist. And here I had to make it negative to make sure our elbow would bend the right way, because before it was like bending this way, which is like backwards compared to which way a real elbow bends. And then after that, we just have this little line of code here. But basically, we figured out which angle the wrist is supposed to be at, and then we know the elbow, it's going to pivot around the elbow, and we just have it target to the shoulder from there, so we don't need to do any special calculations. All of the special calculation needs to just know what our initial wrist angle is, and then we can just plug in everything else from there. Okay, so here I am inside of the main menu, and as you can see, I have some arms, and over here I have the start menu. So let me reach over here and press it, and then it brings up a message that says hold your arms down at your sides and press both trigger buttons. So now when I do that, it should measure how long my arms are from there, and I should be set for the rest of the game. So initially I had that message pop up first thing, but I had a problem where if you had your controllers set down on a table or something, it would press the buttons as soon as the game starts. So I had to switch it around and make it so you press the start button first and then do it. So we'll see if that setting the length of your arms, if that's a good way of doing it. All right, here we are. I have 2 arms, and they feel pretty good. I wouldn't say the elbows line up perfectly with my elbows. And then also when I straighten out my arms, they don't straighten out all the way. So I think maybe the shoulder points aren't lining up exactly the way I want. And also, let's see. Earlier, when I moved my arm over, it just completely like flipped upside down. So I moved the elbow target around a little bit, so it should be a little bit better. But I think if I reach my arm really far back. Oh, no, that's actually not a problem. I thought it was going to be a problem, but it's actually okay. So it's attached to the torso of my character, which seems okay, but yeah, it's just the elbows not lining up perfectly. And I think it would be nice to have the elbow target move around a little bit depending on how you have your hand positioned. But this is a good start. These actually feel quite a bit like arms. Just got to get those elbows in the right place. Alright, so I made a few more changes to the arms. Two small changes that really made a big difference. So the first change is I made the wrist actually turn with your hand, and now it just feels very natural. Before, it was like a target that was just looking at your hand. Now it actually feels like it's a part of my hand. And then the other thing that I did was I created this invisible vector that's attached to my hand, and I kind of average the elbow target with your hand, so you can kind of do like this like chicken arm motion. So yeah, it feels a lot more natural. These arms feel pretty close to being fully functional. Sometimes they don't line up perfectly, but most of the time they do. So I think the next step is to replace these cubes with an actual 3D model that matches our character. Okay, so the IK arm system is almost done. There's just one more detail that's a really small detail, but I think it's going to make a big difference because in VR it was really bothering me and it just didn't feel right. And that is that the torso in VR just didn't quite line up with my real body, and I have the arms in the game actually line up with the torso. So at first I thought I'd be able to just snap the shoulders of the arms to approximately where your shoulders would be, and that would be close enough. But it turns out that it didn't really feel right. So I started thinking about it, and in real life, when you reach for something, your shoulder moves. So you can see, like, if I'm reaching with this arm, now my shoulders are at like a 45-degree angle, and you can really feel that in VR. So it was really tricky, but I made it work with code. So let's go over what I did. It's not like as complicated as the long equation that I did for the IK system, which I can't really take too much credit for because the original mathematicians who came up with the law of cosines are really the ones who originally figured that out. I just kind of copied what they did and transferred it into video game code. But this is something that I was just really stumped on and I had to figure out myself. So what I ended up doing was first I created a variable that saves the direction from your left hand to your right hand. And the way you do that is you actually minus the position from where you want to end up from where you want to start. So I'm going, wait, from where you want to start? Yeah, so, wait, no, the left hand is where we want to start, and the right hand is where we want to end. So that's going to create a vector3 variable that goes from your left hand to your right hand. So that's step one. And then step two, we need to transfer that vector3 variable from world space to local space on the chest. So if we are going from our left hand to our right hand, it could be pointing in any direction around the world in this 3D world. But what we want is for this direction to be relative to the chest. We want to know, is it going to the right? Is it going to the left? Is it going forward? So we want to get that information there and transfer it into local space. And then the next step is that we set y to 0 And basically that is because if one hand is like higher than the other, we don't really care about up and down, or at least I don't think we're going to care. We'll see once we get into VR and see how it feels. But I don't think it's really going to matter the up and down so much as it matters the left and right. I really care about turning the shoulders like that as you reach for something. So we're just going to flatten this vector 3 on the up and down. And since this variable is in local space, we don't have to worry about, for example, if we're in extreme spin mode and our character is upside down, because being local space to the chest, if the chest is completely sideways, we're just going to flatten it compared to where our chest is if we're sideways, if that makes any sense. And then this is the next part that was like really tricky. Ended up being really simple, but I wasn't sure exactly how I should do this. So here I am basically just rotating the direction from our left hand to our right hand by 90 degrees. So if our hands are perfectly perpendicular to the way that our chest is facing, so the vector 3 variable is going from our left hand to our right hand, so it's pointing in this direction. I rotate it 90 degrees so that now it's pointing forward. So now we know which way forward is based on our hands. So let's say my right hand is farther ahead of my left hand, so the original vector 3 variable is pointing in this direction. So if we turn it 90 degrees, it'll be pointing in this direction. So now I know I need to rotate the chest towards that direction because our hands are reaching out like that. And then the very last step is that now we figured out which way we need to have the chest face to actually face which way the chest is pointing. We don't necessarily want to have the chest just lock to that, because I think that might be a little too much. So I created a variable so I can adjust how much the chest is going to stick to the way that it was working before and how much it will kind of weight itself towards this new vector 3 that we created. So basically, I'm just using quaternion.lerp for that. And lerp is linear interpolation, which basically means that we have one direction here and one direction here, and then we give it a number between 0 and 1. 0 would give us back the first direction, 1 would give us back the second direction, and something like 0.5 would give us something halfway in between. So I can take that number and I can adjust it, and I can figure out how much we want the chest to actually follow the hands. So it's not necessarily a bunch of really complicated equations or anything, but it was a bunch of lines of code that was like, I think it'll work. We'll see. So I'm going to jump in VR and see if this makes the chest feel more lifelike and like it really is a part of our body. All right, so there we go. I think these arms are actually feeling pretty good. There's some small adjustments I think I could still make over time, but I feel like it's like 99% there. One thing I actually just realized that I'm pretty sure I forgot to mention is that I actually created a 3D model for the arms. Okay, I just noticed a new glitch and I just hit a wall. So I guess I tested out the game, and one thing I realized is that when I crossed my arms, it totally messed up the whole shoulder reaching system that I put into place. So I had to put a little if statement in there that said, if your arms are crossed, just stop. Just go back to the default way it was doing it before. But yeah, this feels really good. Lagged a little bit there. But one thing I did was I actually modeled these arms, and I'll throw a time lapse up on the screen now, but I just needed a 2D reference of what the shape and proportions of an actual human arm looks like. So I took that classic Leonardo da Vinci picture of him where he's like standing in a T pose, and I just looked at the arm and I kind of lined up a 3D model on top of that, and I'm really glad I did that because that made the arms feel a lot more realistic. Before, I had the proportions of how an arm works totally wrong, and it just, now that I have it the right way, it feels right. And I realized that before, that was not right. Like your what's it called? This part of your arm is I think it might actually be longer than your bicep, and I thought it was the other way around. So now it feels a lot better, and I just added a couple extra details to it, and I think it looks pretty cool. It's supposed to be red, so it's supposed to match my character. I'm not sure why that's not working. I gotta look into that, but it feels really cool. These feel like real arms now. So awesome, yeah. I'm kind of embarrassed that I wrote off this idea of adding arms to the game because I just didn't think it would feel right. But man, this adds a lot to the immersion. It does feel right. Like now that it's in there and it's all lined up perfectly. I mean, there's still a few weird little bugs like that could probably be tweaked out over time, but I mean, just in general, like this feels so much better. Like I feel like I actually have a sleeve or like an arm in VR now. So this is really great. I love this. So something that I am learning to be more and more true is that feedback from the players is the most important thing when making an indie video game. So thank you so much for your suggestions and your ideas and your feedback. I seriously couldn't do it without you, so thank you so much for that. If you have any new ideas or suggestions or just something you want to see in the game, please let me know. It is really awesome to hear your feedback, and maybe in the next video I will take your idea and implement it into the game. I mean, this video, it worked out really great. I mean, the IK arms, they're a little glitchy in some spots, so I think over time I'll be able to tweak them and make it just a little bit better, but it adds a lot to the game, and it's something I should have added to the game a long time ago. So I think I'm going to learn from this situation going forward, and that is if a bunch of different people are giving me the same suggestion, it's probably a really good idea, and I should try to figure out a way of making it work. And I mean, when I get ideas from you, it makes me try to think about the game in different ways, because sometimes I'll hear an idea and I think, would that work? And I have to really think about it. And sometimes, I'll just be going about my day and then all of a sudden I think like, wait, that would work. I'd be able to write the code this way and then maybe that could work. I mean, if you just take extreme spin mode, for example, tons of people requested that I make it so that you actually go upside down on loop-de-loops. And for the longest time, I would reply back and say, no, that wouldn't work. It's not a good idea. It'll make people seasick or nauseous. But enough people requested it that one day I was like, you know what, let's give it a try and just see what happens, and start playing around with some physics and figured out some stuff that I never really thought about before, and it ended up being one of the best features in the game. So I really got to learn from these situations and really take your feedback to heart. So yeah, once again, thank you so much. If you want to try out these new features right now, they're available on the testing version on Steam. So until my next video, I will see you later, and keep making games.